This stove idea uses a heat riser to store heat, and a secondary oxygen feed to finalize combustion of any gasified fuel. The benefit to using cinder blocks is that the design can be modified relatively quickly. The drawback of using cinder blocks is that they are prone to erode quickly from thermal shock. Thermal shock is where objects break when they are brittle and heated unevenly. However, if you can insulate the blocks in cement, cob, or something else, they should last much longer, because they will heat up and cool down much slower. The trick to this design is making two modified cinder blocks. There needs to be a 90-degree turn in the airflow in two places. A circular hole will erode much slower than a square hole. However, a square hole will work. To build this stove, first, flatten out an area on the ground, at least the length of 3 bricks laid lengthwise. If you can, use a long level to make sure it's evenly flat. For the burn chamber, bury a few refractory bricks so that the tops are flush with the ground. Overlap cinder blocks on top of the refractory bricks. The inside of the top block hole is flush with the outside of the block below. The width of the burn chamber should be the width of the cinder block hole. Turn one of the blocks on its side to create a viewport. This port can also be used to start the fire and to clean out the burn chamber. There needs to be a refractory brick sized to cover the opening on the back of the burn chamber. Place one of the modified blocks on top. Now the core is complete. It would be much better if it was solid refractory concrete, but for experiments, this will work. You might notice that the exhaust exit is below the top of the burn chamber. The area above the exhaust port is the heat riser or accumulator. A metal plate placed here will provide heat for cooking. The secondary combustion pipe ends inside the top of the burn chamber. It points up at the top of the flame inside the heat riser, below the cooking surface. The other end of the pipe is below the lowest point of the burn chamber. This will ignite any gasified fuel in the air and increase the temperature of the cooking plate. There also needs to be an extension on the chimney so that it is above any nearby trees and as tall as you can feasibly make it. If there's a tiny amount of wind blowing over the top of it, it will draw air up from the bottom. The higher you get it, the more wind you'll have. Depending on how much thermal mass you have in the stove and how long you run it, the chimney extension may never get hot. A thin gauge galvanized metal tube should work as the chimney extension. You'll want to cover as much of it as you can with as much mud and dirt as you can. Do this in layers to make sure it dries well, especially near the burn chamber. Make sure you wear safety glasses on the first burn. So that's it. Let me know what you think.